we are going to be looking at hypothesis testing, and we are going to move up the food chain to how do you compare two proportions and decide, is there evidence that one of them is bigger than the other, less than the other, or just different? So I'm going to have a little story to start the job. We're going to have two populations in these stories. Population one, who will we pick on? We'll pick on the French because I don't like them. So population one is French, and population two, let's pick on the Germans. And we are going to ask a pretty innocuous question about them. And that is, I believe, and I'm going to see if I can prove it, that more French people go on holiday to a different country than Germans. So you've got a main holiday a year, right? The one you get like 2 weeks off, right? Around Christmas holidays, right? That kind of break. And your main holiday is almost always in the summer, right? Everybody, there's 2 weeks in the summer that they like to specifically have that holiday. So we're going to find out whether there's any difference between French and Germans. So what we did is we collected a sample of 1,000 Frenchmen, and we found out that 421 of them would go to another country to have their holiday, right? Now, if you're in Europe, it's actually very easy to get to another country, right? I mean, if you're in France, you could probably get to 5 or 6 European countries in less than 5 hours, right? Just by flying, easily. And so the Germans got 500 of them. And oops, I forgot to put in the second number there. So uh, 195 Germans in my sample of 500 said that they'd went to a foreign country for their holiday. So the question now is there enough evidence to prove that more Frenchmen than Germans? So I'm going to convert that data into a decimal just to make it easier to compare. So that's 0.421, and this guy is 0.390. So a little bit easier to tell them. But you can read that's 42%, that's about 39. So there is a difference. But the question is that statistically going to be enough? Now, I need a significance level. It could be a 5, a 1, or a 10% significance level, right? And Brandon, you got a preference?
95.
Okay, so we're doing a 5, right? So based on this hypothesis test, we are going to find out, is there enough evidence to prove that the French go on holiday to a foreign country more than the Germans, and the significance level is going to be 0.05. So our first step, let's put this over here. Our first step is to set up what is called the null and alternate hypotheses. Now, the null is typically called H0, and the alternate, at least in this textbook, is H1. And we write it like that. The null hypothesis is that they're both equal. So you might say, why don't we just say P1 equals P2, right? Well, isn't P1 take away P2 equals 0 mathematically the same thing, right? But we describe it in this way because that's kind of the formal way to do it. Now, I want to know, is this guy bigger than that, right? That's my alternate. That's what I want to see if I can prove. And we write that one also in terms. Now, if I tell you P1 take away P2 is bigger than 0, isn't that the same thing as P1 is bigger than P2? Okay. So in my story here, that's what the null and alternate would look like. Now, there are 3 versions, just like there was yesterday for a single one. Let's do it in red. The null hypothesis is always going to be both guys equal 0. And the alternate hypothesis could be the first guy take away the second guy is greater than 0. The second one is that one. Wouldn't that be the equivalent of saying that this thing is smaller than that? And then obviously there's not much left because there's only 3. And you always get that as your null. And let's see what the alternate looks like. What do you think the third and final one is? You're bigger, you're less. What should this one be?
Greater than?
Oh, we've got that. It's here. What else?
Almost equal.
Not equals to. Yeah, great. Is it not exactly the same 3 situations as yesterday? Only yesterday it would be P bigger than a number like 0.4, P less than a number like 0.4, or P not equal to a number like 0.4. So yesterday, wasn't this a number? It was 0.1, 0.7, 0.5, 0.4, right? It was always a number, right? So 0.4, 0.4, right? So there is a little difference, but only a little. So are we comfortable about one of these 3 is going to be the null and alternate hypothesis for whatever story that you happen to have here, right? So far, so good? Right. Now, at the next point, we would calculate you can hear a dog at the background. It's Bailey telling me that there's a leaf falling. So we're going to calculate by using salt. So we're not going to do it by hand. It is possible to do it by hand. It's very messy. It's even a lot messier than the one yesterday, but salt kind of makes life easy for ourselves. We're going to calculate the estimated answer. So this one I can do. It's 0.421 take away 0.390. In this case, that's 0.031. And that's called a point estimate. That's the name of this thing. We also are going to calculate the z-score. And the z-score is given by this formula. Where S of E is fella. This guy here is called the standard error. Does anybody know what they call the z-score? It's got a funny name. Standardized test statistic. So if you ever see that phrase, it just means the z-score. Now, the z-score would be, if you wanted to do it by hand, would be P1 hat take away P2 hat over the standard error. This standard error has got this ugly formula. At least there's 2 versions of it. This is the one I'm going to be using, which would be that guy. So you would calculate this, you would then calculate the z-score using this piece of information. You would then get the p-value. And the p-value is what's the probability that you get a z-score, whichever that is, greater than this number. So I guess I should calculate it once. I was thinking about it. So what's it going to be? 0.031 divided by this ugly guy. So let's show you why you wouldn't normally use salt. Just do it once, I guess, for completeness. So P1 is 0.042, 0.421 times what you get when you take that away from 1, which is 0.579 divided by 1,000. So that's that bit. Add, let's do this bit. It's 0.39 times what you get when you take that away from 1, which is 0.61. And that's going to be divided by 500. And so you take this guy and divide it by 0.0268 and stuff. So 0.031 divided by the answer is about 1.156. Okay. So you find the p-value, which is a probability you get a z-score greater than 1.156. And in a lot of homework questions, you get 4 pictures and you put 1.156 here and they shade a little bit to the right. That's what it would look like. And this you have to do using salt, and then you have your conclusion. So your conclusion is going to be the test. And you always ask the same question. Is the p-value less than the significance level alpha? Well, I don't have this p-value yet, and we need to get it. So you hold on a second while I get this thing set up. Here we go. Right. So I'm actually going to go through most of those calculations using salt for all of them. Right, so there's salt. Now, two population story. You go over here and you do 2 sample proportion. You see it? 2 sample proportion now. Click. So all the questions from this section are going to be 2 sample proportion. The first one were the Frenchmen, and there was 421 of those guys. And the sample, the number of trials, was 1,000. The Germans is the second group, and the second group had 195 out of a sample size of 500. It's a hypothesis test. The difference is 0. So that we keep. We don't need to change that at all. And we were trying to prove a greater than. And so I should be able to just generate results. And here are all the numbers. And the guy that I'm interested in is the p-value. Do you notice that their statistic is 1.150 and mine was 1.156? Do you notice that? I think that was just caused by rounding off. It's not that I'm doing it wrong. So the p-value is that number there. So I'm writing that down right now. 0.125, that'll do. So all the numbers that I wanted, you could have got them simply by using salt. Right, well, here's our question. Is our p-value 0.125? Is that less than 0.05? And the answer is a big fat no. Agreed? And we don't like no's, but if that's what you get, that's what you live by, right? Isn't the conclusion then not enough evidence to reject the H0? And so we would say not enough evidence to tell if there's any significant difference between those two populations. Compared to yesterday, isn't there, especially if you think about salt doing the work for you, isn't it very similar to yesterday, right? But you do it with two populations instead of one. So let's do a clinical trial. Now, in a clinical trial, don't you normally have two groups, right? And what you have in this story then is you're going to have population 1. And I don't like that kind of changing. And population 1 is going to be, in this case, I'm going to call it the control group. And the control group are going to receive, try to think of something you may want to cure. Suppose it's a cream for eczema, right? So you've got eczema in the skin and it's dry, it's irritating, and this is control group, and it doesn't work well for everybody, and you have some kind of measure of success. And the control group, they get the cream, and there's 100 people in this group, and the number of people who indicated that it did a significant improvement to their condition was 58 out of 100, right? All right, about 58% success rate. And the second population is going to be our control, not a control group, our experimental group. And they also get a cream, but it's a new, I don't know what you treat eczema with, it's a new steroid cream or something, right? And we're going to see if it's better, right, than the old one. So we got 150 in this group, and the success rate out of that 150, let's see, was 95. And we're going to give it a significance level of 0.01. So our question is this guy better than that one? But that's not going to be the way it's going to be actually set up. I'll show you what I'm getting at. The null hypothesis is that there is no difference, right? P1 represents the population proportion, right? P2 represents population 2's proportion. And we're saying that the difference between them is 0. There is no difference. That's classic. That ain't going to change. But actually, if I want to prove that this is better than that, aren't I trying to prove that the difference is negative? Does that make sense? Although I'm interested in this being bigger than that, aren't I going to phrase it as, I want to prove that this is smaller than that? Right. Logically, it's the same thing, isn't it? You're smaller than me, so I must be bigger than you, right? But that's the way you always do it. You always do it as P1 take away P2, right? What does that look like? Bigger than, less than, and not equal to, right? So that's what we have here. Now, all the information that we need is going to come directly from SALT, but I'm just going to write down all the numbers that we might be asked in a homework question. Right, so that's typical kind of things that they ask. And let's go and check it out. So it's really using SALT. To sample proportion, that's not going to change. The first group, the control group, had 58 successes out of the 100 people taking part. The second one, the experimental group in this case, there was 95 successes out of 150. That's going to stay put as 0, and we're trying to show that it is less than. And so when I generate results, we get that. Now, the thing that they're calling the common p, or the difference I should say, is this number up here. That's the one we want, right? The difference. That there isn't really interesting, so I'm not bothered about it. That's the standard error. There's your Z statistic, and there's your p-value. So I'm only going to write down the p-value, which is 0.198 to 3 decimal places. So can you imagine, I could have wrote down what those numbers were, I just chose not to. I only figured that's the important one, isn't it? That's one that's going to decide evidence or not. So here's to finish with, I guess I'll put it up here. Is our p-value less than the significance level alpha? Is 0.198 less than 0.01? And that is another no. So essentially, isn't that not enough evidence to reject H0? So if you were if you were the pharmaceutical company, you wouldn't be able to prove that your new cream did a better job than the old cream. And so the chances are the FDA would never approve it. One of there's various rules that the FDA have. One is you've got to prove that it is statistically better at doing the job than the drugs that are out there. That's one of them. The second one's kind of obvious. They don't approve a drug that's very dangerous, right? If you're curing eczema, but 10% of the people who take it die of heart attacks, I'm being silly here, you'd agree they would never allow that on the market, right? That's just not a good drug, right? And so that is typically the second thing is safety, right? So you've got to prove that it's better, and you've got to prove that it's safe. And normally, if you get by those two things, you'll be able to go into production. So since I've had 2 failures, I'm going to see if I can make up one that works. So population 1 and population 2. And population 1 is going to be Scottish people, and population 2 is going to be American. And we are interested in the percentage of adults in each population that are overweight. And I think the way that they check for obesity is it the, oh God, is it called the BMI? Help me out here. Is it your BMI index?
Yeah, BMI.
BMI. Is there a magic number that you're fat if you've gone beyond it? I'm not being specific, but you know what I mean. What's the overweight number? Does anyone know?
It's all proportional to the body. So
okay, so there's some test that you do in a person, and you can decide if they're obese or not. So let's say in Scotland, that out of 500 people, 200 were considered obese, right? Out of 500 adults. And there was 400 Americans in this test, and there was yeah, that should do. And significance level, I'm going to go for 0.01. Right. So we are interested in setting, and I want to prove, is there evidence that they're different? So I don't care if they're bigger than, one's bigger than the other. I don't care if one is less than the one, right? I just care that they're different, right? Could go either way, I don't care. Although if you look at the data, it's pretty obviously it's going to be one way or the other. But let's suppose I'm just interested in proving they are different. Then the null hypothesis will begin with P1 take away P2 is 0. And the alternate is that the difference between them is not equal to 0, right? Because that's what I'm trying to prove, that they're just different. And I've hopefully picked such big discrepancies that I'm going to get a significant result. So Scotsman first, 200. 8,500 Scotsman. And there was 210 out of 400. And we are trying to prove a not equal to. Do you see that? Not equal to. So generate results. And yay, I did manage to do it. Do you see the p-value? Nice and tiny. You can certainly write down the other ones because they probably tell you to do that in the homework. But right now, I'm only focusing on the last one because that one is going to be the go-to guy. So here we go. There's our p-value. So we now do our test. Is our p-value less than the significance level? Have you noticed that it doesn't matter whether you're trying to prove something's bigger than something, less than something, or not equal to something? Isn't the test always, is the p-value less than alpha, right? Always that. And in this case, is this tiny number less than that one? And finally, we got a yes. So we could say, well, there's all sorts of versions of this sentence, but how about this one? There is enough evidence to reject, H naught. And in English, we would say there's enough evidence to prove that the rate of obesity in Scotland and America are different from each other. And it wouldn't take much for you to say Americans are fat, at least based on this data. And this is a formal scientific proof of something, rather than me saying, well, it's my gut feeling that this is true, right? Or I believe this is true. Or look, that's bigger than that. That makes it's obvious that they're different. It's not obvious just by looking at two samples proportions, that because one of them is bigger or less than the other, that is not evidence that they are bigger or less. Couldn't that just be evidence that the samples you've got just happen to be that way? Couldn't you take another sample from here and a different sample from here? And couldn't the stories switch places even, right? Especially if they're very close to each other. And so we can't just base our answers on these. We have to go through a much more formal process, and we are finding p-value. P-value is essentially telling you how unlikely it is to get this kind of result if both populations were the same, right? This would only happen, what, 1 in 10,000, 1 in 5,000 times, right? You'd have to do it 5,000 times, and only one of those times would you ever see that, and the other 4,999, you wouldn't see that, right? So that's our evidence, right? That it's so unusual that that's not true. And if that's not true, then the alternate has to be. That's kind of the logic. Are you okay with the logic behind hypothesis, right? You say that they're equal, and then you go hunting to say why it's not. And the why it's not is a tiny p-value, right? The p-value has another meaning. It's also the probability that I'm wrong. So I've made the assumption that Americans and Scots differ, right? They're different in how much obese they are, right? And I've said, sell your house, this is true. But technically speaking, couldn't I be wrong? And this is just 0.0, isn't this just one of the flicky ones and I actually found it? Well, what's the chance of that happening it's like one. It's like, if you round it off, it's like 1 in 5,000 chance of it happening. And we know that when we do hypothesis tests, we are not saying absolutes here. We're not saying it's guaranteed, it is definitely this. We're kind of being a little bit vaguer than that. We're saying like we're 99.9% sure it's this. That's essentially what that is, right? 99.9% sure it is, but we're also 0.000183 that it might not be that, right? It could be just bad luck. Any questions about that so far? Right, so I've finished with all my made up ones. Let's do some practice on theirs, because the chances are that they have ones that come out nicely. So I'll switch over. Oh, if I get something in the chat. So Sinclair, when I said, how do you know if it's less than, is that one of my stories, or did I answer it during my conversation? Are you still got a question?
So like when we're in Sol and like after we filled everything out, and then at the bottom, like when it, like the one that was like less than, greater than, like, I don't know, I'm just confused on how do we know which one to put in there?
Well, let me show you question one, and I'll show you how I decided that, right? And it's pretty easy once you've seen a couple.
Okay, thank you.
Let's see. Right, so here they have a story about do you favour spending more money on tax, on arts, I should say. And they asked women and they asked men, right? And so what would the difference say? Now, at this point in the sentence here, do you see it says, does this information indicate a difference either way? That means not equal to. If they had said, who's first? Because you have to know who's first. If they said, is there evidence that women would spend money more than men, then you would be doing greater than, right? Women are first, right? N1 is first. So women greater than men, greater than symbol. If they said, is there evidence that women would do it less than men, right? You do it the other way, right? So in this case, it says, do they differ either way? That is a not equals to. Let's skip to the next question. Okay, do you see this one here? Does this information indicate that the population proportion of conservatives spend more? So in that question there, can you see conservatives more than the other group? Assuming that's liberals, that would be a greater than story. Let's see if I can find a less than story now. No, see, that's a different in either way. So won't that be a not equal to again? I'm trying to find, you know, I'll probably not find one that I'm looking at. That's a different either way. I won't do that one again. Do you see this one? It's, where's the word? The voter turnout was higher. Wouldn't that be a greater than again? I might not find a less than. I'll keep going.
I have a question when you're
you get lucky.
Your question.
Yeah.
So I was struggling with yesterday when going through these ones where it's the like very last part where it's saying like you either reject a null hypothesis, you fail to reject it. Like I don't know if it's just the way I'm trying to read them that I can't, like, I get everything all jumbled up together. I don't know if I'm the only one who has this issue.
No, it's very often, it's a very lawyerist language, isn't it? Right, the short answer is I haven't found a less than, but if there was, it would be males less than females, right? You'd be looking for a less than in the sentence. Now, what Leanna was talking about, if I pull back a minute, and if I think I can address the question, there's a bit at the end where they have a failed to reject and all that sentence, is that right? Okay, so let's suppose that we have a null hypothesis and an alternate hypothesis. And in this story, it's going to be equal to 0 in the other one. Let's just say it's greater than, right? Just for argument's sake. Right? And you got to the p-value guy, and you did the p-value less than alpha, and the answer you got was no, right? So that could be because this was 0.11 and it had to be less than that, right? But you got a no, right? No means fail to reject the null hypothesis. Oh, so I better put, I put in H naught, but if you want to call it its full title, right? So that's the same as saying fail to reject H naught, right? So if you get a no, this is the lawyer-esque sentence that you're going to start with. There are a bit to come after that, but this is what you've got. Can you imagine you did the test, is the p-value less than alpha, and you ended up with a yes as your answer. Now, when it's a yes, you are not going to write fail to reject the null hypothesis. You're going to do reject the null hypothesis. Or reject H naught. I like that because it's easy to say. So that's the first half of the sentence. Have you noticed that they then have a comma and then they have another half to the sentence? So you're almost guaranteed in these questions to have 4 choices. There are going to be 2 that says fail to reject the null hypothesis, followed by some sentence. And then you're going to have 2 that will say reject the null hypothesis, followed by 2 sentences. So let me tell you what the second half of the sentence is. If you fail to reject the null hypothesis, then that means there is insufficient evidence to prove whatever it is you were trying to prove, right? So it may be there is insufficient evidence to prove that Scots are heavier than Americans, right? Or there's insufficient evidence to prove that women like horror movies more than men, right? Whatever the story is, that's what the ... part will be followed by. Right? On the other hand, if you get this situation, right, where there's a yes and you reject the null hypothesis, instead of there is insufficient evidence, we would write down there is sufficient evidence to prove right? So there is sufficient evidence to prove that Scotsmen are fatter than Americans, or Scotsmen are less fat than Americans, or that there's a difference between how fat they are, right? So you have a fail to reject the null hypothesis, followed by that means there is sufficient evidence. There is insufficient evidence to prove things, or you have the reject the null hypothesis, in which case there is sufficient evidence. So let me put a story on that. Let's suppose we did females and males. And that's going to be 1 and that's going to be 2. And the null hypothesis, as it always is, that there was no difference between them. And let's suppose we asked them, do you like horror movies, right? Just for argument's sake, right? And we came up with the evidence, right? So the alternative is we think that women like horror movies more than men, right? So that's what we're trying to prove. And we found out the proportion of women, the proportion of men, we've done all the good stuff. But the bottom line is that we found a p-value. And the p-value happened to be that guy. Oh, and the significance level, let's say, was 5%. So are they the same, or do women like horror movies more than men? The p-value for that situation ended up being this. And so our test is our p-value less than alpha? So we had this guy less than that one, and that is a definite yes. Great. So we would finish with our choice of sentences. And the first one is we reject the null hypothesis. That is the lawyer sentence for what a yes means, right? We have evidence, we reject the null hypothesis. We can then finish with, there is sufficient evidence to prove that, in my story, women like to watch horror movies more than men. Is that the kind of thing you were wanting some clarification on?
Yeah, because I kept like I had it. I think I had it backwards on what they were trying to say, and I was like, oh. And I'm like, this makes sense, but then I'm like, kept getting it wrong. I'm like, I don't get it. So you explained it perfectly.
You're cool. Okay. Right. I like questions because I guarantee you're not the only one that had issues with that same idea, right? And the same with Mackenzie, what was less than, what was more than. I still haven't found a less than. You know Murphy's Law. I won't have any of this set of homework, but it can exist. So I believe we can now go back to our first question again. We'll just go through the whole process. So it's, do you favour spending more money, more taxes on the arts? And so they got a random sample of 238 women, and I'm writing this down, 238 women, and 57 of them said, yeah, I don't mind paying more tax for the arts. And then they went and asked men, and there was 161 of them. And out of that 161, 52 of them said that, yeah, I would pay more money for the arts. Now, some questions are so silly that you wonder what the question's about, and I've just noticed that the answers are not much. I wish it would stop defaulting to that. So, okay, so did that go away? Yay, okay. So what is the significance level? Isn't that this guy here? So 0.05. I guess they asked that just to make sure you're paying attention. Now, in this story, does this information indicate a difference either way? So the null hypothesis would be that they're equal. Oh, okay, well, I still do P1 minus P2, and the alternate is not equal to, so it would be that one. I don't know why this textbook does it its own way, but this textbook has 8% confidence intervals, so it's not a surprise they do things their own way. And are you okay with that's the same thing as I did? It's actually maybe slightly easier to see it. Not equal to, because does this information indicate a difference either way? That's how you would phrase not equal to. Now they talk about what is the sampling distribution. We'd say it's normal. And then here, guess what? Just to be the pain, don't they then return to P1, take away P2? I wish they just did P1 minus P2 all the way through, but never mind. All of these guys here, right, are going to come from salt. So let's just hit salt and get them. So it's going to be 2 sample proportion. The women go first, so that's 57 of those are in favour out of 238. The men go second, there's 52 of those, and that's going to be out of 161. And we are looking for make that 0, which it is, and not equal to, which it is. And here are all the different numbers. For instance, there is my p-value. So I'm going to copy that. And there's the p-value. and I'll round it off to 4 decimal places. So that's that guy. Sometimes WebAssign drives me crazy. Read this sentence the way I'm reading it and tell me, does this not contradict themselves? Do not use rounded values. Round your answer to 2 decimal places. What in heck? Am I the only one that's wondering what they mean? Agree. I think what they mean is use very accurate numbers to do the calculation and then round it off at the end, right? But I think they're assuming that you're going to do it by hand. But if you are thinking about that, all I need to do is go to the salt that you can't see, and it tells you what the difference is, and the difference is that guy. And I'm going to round that off to 2 decimal places. Okay. So the difference between P1 and P2, I'll show you what it looks like in salt. You see they call it the difference in proportion, right? So they're a slightly different name, but that's where that negative 0.83 whatever came from, right? It's there. Now, you are looking at a number that's negative, right? And so it's a 2-sided guy, so you'd be picking this one. Now, you might say, well, that's a negative number, which I agree, but aren't we looking for not equals to? And not equals means that it could be in either side. You're making no assumptions at the beginning where the difference is. Like maybe the next time it's at the other end, right? It's at the plus side. So that's what you do. So if ever you get a not equals to, right, which is sometimes called a 2-sided test, if you like its name, and not equals to, always pick the picture. It's got a guy either side because it will be in. Now, based on our answer, which is this p-value, you see it, 0.06 and change. Based on your answer in part A to C, will you reject or fail to reject the H0? Well, would you agree that that number is not less than 0.05? Isn't that a no? Right? Is our p-value less than 0.05? No, it's not. And if it's no, it's not, then isn't that a fail to reject? Now, I have a fail to reject here, and I have a fail to reject here. One of these is the right fail to reject, and the other is the wrong. And we find that by the sentence that comes after that. We've failed to reject the H0 and conclude that the data is not statistically significant. That is failed to reject. That's the full sentence. Do you see this one down here? You fail to reject and conclude that the data is statistically significant. Isn't that total opposite of what, you know, rejecting, did I say fail to reject? Yeah. Isn't that the total opposite of what failing to reject the null hypothesis means? So that one's just wrong. So that's the right answer. You fail to reject the null hypothesis, and the conclusion is that nothing statistically significant is going on. Now, if you turn it into a more English version, you fail to reject again, and insufficient evidence. Right. So that's the same. So that's kind of a more English version of the one that was above. So one's kind of like a lawyer, which is that one. And this is a little bit closer to being English. And that's pretty much what a hypothesis test looks like, right? When you're comparing two proportions. Any questions about this one before we move on to the next one? Okay. Question 2 is just a duplicate.
I have a quick question. Sorry. Yesterday when we were doing it, you said that the sample statistic was the
Z-score.
the Z score. So this time, now that we're doing two, it's a difference in proportion.
No, the test
Okay.
statistic is still a Z-score. They just didn't bother to ask you in this question.
Okay, I misunderstood you. Then I thought we were supposed to take the number from the SALT score that said different in proportion and put it in.
No, the difference in proportion is, what do they call it? Yeah, they call it the test. I see what you're getting at. They've used the word test here, haven't they?
Uh,
Yeah,
Yeah,
but
it just-
it's not a test statistic. It's just,
okay.
yeah. In fact, I wish they hadn't bothered with any of that.
Yeah, it's a bit confusing actually.
It is. Yeah, it is very confusing. But so's calling it P1 equals P2, and it should call it P1 minus P2. I think we just have to get used to the idiosyncrasies. The reason why I'm skipping by question 2 is it's really just a duplication of question 1, right? It's the same story. I believe the only major difference is that this time you're trying to prove that it's more, right? So it's a greater than, which would make it that one. Okay, question 3. A random sample of 156 people aged 16 to 19 were taken from the island. I don't know how to say that. Oahu. Oh God, I'm not done it. Oh, stop laughing, Mackenzie. You tell me what that blinking island's called.
Oahu.
Oahu. Was that close then? That sounded sort of a China. Right. Oahu. Right. The O Island. I'll play it safe. 16 were found to be high school dropouts, so I better keep track of that. So 16 out of 156 from the O Island. A different random sample of 133 people in the same age group were taken from a place in Wyoming. 5 were found to be high school dropouts. Okay. Does this data indicate that the population proportion of high school dropouts from O is different? Oh, it's another not equals to that of Sweetwater County. Well, the level of significance is 1%, which we write down as that. We know that they're going to be equal, and we're trying to prove that they're just different, so it's going to be that one. And the sampling distribution we're going to do is it's normal. Actually, you could say that one as well, but yeah. Try that one. If it doesn't work, try that one, because they're both true, but one of those may be more important than the other. Right. Now I should check this. Can I do a check? No, I can't. Okay. Hold on a minute. I want to do something. Let's do a student view. And let's click on this one. Come on. I want to be able to put some numbers in because you've got me guessing now that about that test statistic. Because the test statistic should be the Z-score. And I get distracted by that P1, P2 thing as well. Okay, so in this case, the numbers are going to be 10 out of 141 because every time you go in, they change the data. And the other sample, it was 5 out of 134. And we're trying to prove that they're different. So significance level is 0.01. So let's check that. I'm sure that is right. But just want to make sure. Yeah. So they don't want you to put in the number 1. They want you to put in the decimal version of 1%. Now, we know that it's different in some way. Let's check that. In case that question do they? Yeah, different in either way. So that should be okay. So I'll click on that. Okay, we're good. Now, this is one I was having trouble with what they wanted the answer to be. Now, we know that it's normal because it's proportions just generate normal distributions typically. So it's standard normal. And is the main reason is because the data is sufficiently large, or that we're assuming that it's approximately normal. Now, both of those are true. So what I want to find out is whichever one they want is going to be the same answer all the time, right? So once we figure out which one of the two they are considering more important. So pick the top one. And so they are considering that the sample was just big enough. Okay, so it's standard normal, which it is in both questions, but the main reason is that the data is sufficiently large, which is true, it is. Now, that's the next guy I'm worried about, because they call it the sample test statistic. And we are going to have to figure out in a minute which one of the two guys it is. So I'm going to go in here and put in the O island. And put 5 and 134. All of that is good. Not equal to is good. Generate results. Now, I believed it was that number the first time, but I think it should be that number. So I'm going to pick the Z-score first. And then that means that all this P1 minus P2 stuff and don't round off, but do round off doesn't matter. And if that is correct, this guy to 2 decimal places ends up being 20. Okay, then they are wanting the difference, which is that number. I don't like that answer, but to 2 decimal places it is 0.00. What are they wanting? What are they wanting? It's only 2 guys in town. Okay. Hold that thought for this question. The p-value is obvious. Oh, wait a minute, is it? Did I put this data in the right way around? It was 10 out of, it's 10 out of 141. Okay, sorry about that. 141, I just changed it. Generate results. Okay, so now we have this guy. Let me pick that is the new Z value. See if that makes it what it should be. So that's 1.123. It is a Z-score, as I said. Of course, you have to remember to type in the right numbers when you do SALT and not 241 when you should have done 141. The p-value, which you cannot see, is about to be put in, and it's a ridiculous number, which if you look at that, rounds off to, well, that 9 becomes 0, that becomes 0. I guess technically to 4 decimal places, it's that guy. Let's see if I've rounded that off correctly. What do you want?
I think it would turn into 2200, not 2120. They were both 9.
They were both 9.
Put another 0 in there, and then you should be okay.
4 decimal places.
Yeah.
Looks good. Yeah, looks good. There we go. This is a two-tailed test, right? It's a not equal to. I don't even really need to pay much attention. Isn't that the only one that has a bit either side? When it's a not equals to, that's the picture. But just to convince everyone, we will do this one. Right? Correct? No green mark. Right. We're doing that yucky test thing now, Leanna, right? So that's the last bit of the puzzle. And would you agree that that is a horrible p-value, and so the answer is going to be no? And that means then that we are going to fail to reject, and the data is not statistically significant. And we are going to fail reject, and there is insufficient evidence, right? That's the two versions of that story. So those are what, if the p-value is not less than alpha, that's basically the two versions of the answer you're going to get. Apart from a little hiccup there, at least we now know what's being asked of us. So let me go back to that Z-score that was bugging me. See all this stuff here? Wouldn't it have been much better if they just didn't write it at all? Wouldn't it have just been, tell me the test statistic, oh, I know it's a Z-score. The only reason I think that is there is that I think some people might be doing that still by hand, right? The whole calculation, by hand. In which case that might have been useful to make sure you round off correctly. That's basically the same question again, but with different numbers. Okay, let's have a look at our next guy. A random sample of 287 voters in California showed that 150 of them voted in the election. So 150 out of 287 voted. In Colorado, which is the one we're going to compare it to, 127 out of 210 voted. And we're being asked, does this data indicate that the proportion of turnout in Colorado is higher than California? Well, since California is first and Colorado is second, if you're trying to prove that Colorado is bigger than California, you are essentially trying to prove that one, aren't you? Okay. Now, it's going to be the same question every time, but now we know what the answer is. Isn't it going to be sufficiently large? Now, this is going to be our Z-score. So won't we just ignore that sentence now that we know what it's about? And won't this be our p-value? So provided I put the right numbers in, we should be good. So California goes first. There's 150 of those out of 287 possible votes. In Colorado, it's 127 out of a total number of 210. And we are trying to prove, well, this is the problem with the way SALT is doing this. Won't we have to convert this to P1 take away P2 less than 0? So it's not a biggie, but we have to understand that. So although we're trying to prove Colorado is bigger than California, doesn't it end up being California has to be less than Colorado, right? So it's a less than situation, right? So it's A is bigger than B is the same thing as B is less than A. And that should be enough to generate all the numbers that we want. And the Z-score is the test statistic. into 2 decimal places. We got that guy. And the p-value, which is the chance that you would have got that result just by randomness, into 4 decimal places is that guy. What was the significance? Oh, a 5%er. Would you agree that this p-value is less than 5%? So we got a yes. And in this story, aren't we trying to show it's a less than guy? So it's this one. And now we've got a yes. When it's a yes, right, we reject the null hypothesis, right? It's not we fail to reject, we reject the null hypothesis. So it's either we reject the null hypothesis and the data is statistically significant, or that we reject it and the data is not statistically significant. Would you agree that the top one's a sensible one of the two? And now you turn that into English, a little bit more like English. You reject the null hypothesis, there is insufficient evidence, or we reject the null hypothesis, there is sufficient evidence. And that's the one we want, isn't it? Because that makes sense, right? There's sufficient evidence. I'm going to hit submit and I'm crossing some fingers because I want to see nothing but green check marks, right? Here it goes, boom. Okay, what was the only one of these I got wrong? What's wrong with it? Oh, shoot in space. Shouldn't that be equals and the other one should be less than? Oops. Shouldn't it be equal and then less than? Yeah, okay. Don't feel so bad. That was just silly. Am I good or am I good? Eh? I'm just too cool for high school. Do people even say that anymore? I'm too cool for high school. No, is that only old fogies like me, Zach?
I mean, I feel like it's still a thing. They usually say too cool for school.
Just too cool for school now?
Yeah.
Is that what the young kids are saying today?
I mean, I don't know how many young kids are saying that, but probably because they've heard us older folks say it first.
Okay. Good. I'm that old that I say the older phrase that the older folk don't even use, right? So I'm above the older ones. I'm the next level up. So, okay. Well, that kind of worked. Right, question 6 is basically the same kind of story again, different numbers, so I'll skip by that one. What's this one about? Oh, okay. Based on information from a previous study, 38 people out of 102 who didn't attend college believe in aliens, essentially. So that's 38 out of 102. About 38% roughly. And if you did attend college, the answer is 53 out of 102. So one population, about 38% of them believe in aliens, and the college student population is about 53%. So definitely a difference. We're being asked here, does this indicate that the proportion of people who attended college and who believed in extraterrestrials is higher than the other one? Okay, I can take that. Significance level is 0.01. The null hypothesis is that they're going to be equal, so it's one of these three. And we're trying to prove that this one here, aren't we trying to prove that this group is bigger than that group, right? Don't go to college, it's about 38%. If you did go to college, it's about 50%, right? So that's the order. We're going to go for sufficiently large because that's the same answer for all of them. And now it's time for this to take over. So it's one. That's a fluke. 150 is, oh, different numbers. Okay. That's 38 out of 102 people who have not been to college believe that there's such a thing as aliens. And 53 out of 102 is second group. 0, and we're trying to prove that P1 take away P2 is less than 0. Isn't that the right direction for us? The second group's bigger than the first, so the difference must be negative. And now we are going to generate results. And I just noticed that I have no control of it. Do you notice that the right H0 and H1 the way they should have? Do you see SALT does it the way it should be written? Yet the question does it in a slightly equal format, but different as well. There's my Z statistic. So let me copy that guy first. So the samples statistic is that guy, and the p-value is that guy. And you're rounding off to 2 decimal places gets me that, and rounding off to 4 decimal places gets me that. Would you agree that this p-value is less than that number? Yes or no? Is 0.0173 less than 0.01? No, it's not, is it? It's close, but not. And so when it's a not, don't we have, well, let's do the less than part, which is this picture. So that's going to be a fail to reject. And I get 2 fail to reject, not statistically significant. Then I'm going to have a fail to reject, not enough evidence choice. So fail to reject, insufficient evidence. Okay, go for it. And evidently, I'm now too cool for school. Liana, I used your phrase and you didn't even notice. Too cool for school. Okay.
I like it.
Okay. Here we have, I think that's basically just another version of the story. Yes, it is. And okay, our last one then. 9 and 10. Do you prefer paintings in which the people are fully clothed? The question was asked by a professional survey group on behalf of the National Arts Organization. A random sample of 57 conservative voters showed that 44 out of 57. So evidently, if you vote conservative, which I guess means Republican, then you prefer people that have clothes on in paintings. And in the other group, it was 35 out of 61. And they were people who were liberals, which I assume is mostly Democrats then. The significance level in this story is 0.05. So we pretty much got a different story, but it's the same kind of information. So 0.05 goes there. It's does this indicate the proportion of conservatives is higher than males? Okay, so I can do that. So it's equal, and the first group is bigger than the second. You agree it's that one? And then we know this one because it's probably that one. What is the test statistic? Well, I won't know that until I put the data in, so let's do that now. 44 out of 57. And then it's 35 out of 61. And it's a hypothesis test, and we're trying to prove the greater than situation. And so we'll generate results, and here are all the numbers. So the Z-score is the test statistics, so it goes here. And then the p-value goes directly underneath, just here. And now I'll round this off to 2 decimal places. And I'll round this fella here off to 4. Which ends up being that guy. And the question now is this fella less than 0.05? And the answer is yes, it is. So we are looking at proving that one is bigger than the other. So a bigger than is that story, right? Just this one here. And it's a yes to our answer, so that means there is going to be evidence, so we're going to reject the null. The data is statistically significant. We're going to reject the null, and there is sufficient evidence to show that conservative voters prefer fully clothed people in paintings. How do you feel about this process? Is it getting a little bit more mechanical, right? The data is there, change the story, but not really the process, right? You do the same thing pretty much each time. You got to try and read a little bit into when are you trying to prove that they're different? When are you trying to prove something's bigger or less than the other? That's about the major decision. And then later on, don't you have to do the is the p-value less than alpha decision? And if it's yes, you go one way, and if it's no, you go a different way. And I believe, yep, the last one is another one of those stories. I think this is a natural finishing point. So last names and bye-byes. And I still think I'm too cool for high school, Yana.
You sure are.
Ah, okay, that works.
Thank you.
Zach, on the other hand, just thinks I'm too old for high school.
Yikes.
What was that joke? Someone went and said a really cool joke for you. Go, there was a comedian who was on TV who said, you know, high school was the best 12 years of my life.
That's funny.
Have a good day.
All right,
Have a
thanks.
good day, everyone. Bye-bye.